Well, welcome to class today. We're going to have a little demonstration about what you read in the articles that I sent to you online, specifically talking about hormones in food and specific to this class, the use of hormones in food animal production. So in the articles you read, what species were they talking about the most? Cows, beef cows, right? And the use of hormones in the feedlot phase or the finishing phase of beef cattle production. Let me ask you real quickly, are cows, beef cows, the only animals we use hormones in for production? What else? Chickens. Where'd you hear that? They tell you that at Chipotle or something?
I hear that one.
Okay. So just so we clear the air very quickly, it is against the law, so there are federal regulations that we cannot use hormones in poultry or pork production. Okay, so that's against the law. They are approved for some ruminant species, specifically beef cattle and dairy cattle, where they are used the most. They could be used in sheep, I suppose, but they don't use those very much. It's mostly, most of the press and most of the information surrounds beef cattle production or dairy production for milk. We're going to focus specifically on meat today, or beef very specifically. And I've got some stuff up here because you read this article and it talks about how bad those hormones are. And what group of people was it referencing specifically?
European Union, wasn't it?
Well, the European Union, the scientists from the European Union were the ones, making the claims in that specific article. But what consumer group are they the most concerned about with the use of hormones in, let's say, beef production?
Pregnant females.
Possibly pregnant females. Who else? Young kids, right? Prepubertal. And so there's a lot of concern out there about the use of the hormones that's in the meat and the potential for that to cause some issues or prepubertal development, especially in young women, okay, which could potentially lead to what? Breast cancer, okay? So that's one of the big concerns. And so along with the articles you read, what I'm going to ask you to do is a couple things here, because we've all seen all these types of images, marketing, media, you name it, that kind of gives us the aspect that we're pumping these animals full of a lot of different things, whether it's chemicals or antibiotics, which we'll talk about in another discussion. But specific to hormones, we see all these things and all these images, and it kind of makes us a little bit worried about what we're eating. So when we talk about hormones, and you guys read both those articles, I'm sure there's some data in there that may be a little bit confusing to you. So I like to do this little demonstration. I first did it about 6 years ago for a group of high school students in the center of San Francisco, and I've been doing it kind of this way ever since I've taught this class. The last few years I've done this same demonstration in every class. So what it does is it allows you to understand the actual level of hormones in different food products that you may eat, and beef is one of them in there. I've got 2 pieces of beef, and I'll explain that here in a minute. But I'm going to ask for somebody to come up and try to match some of these things up for me in a little bit, and I'll tell you exactly what's on that table. But what I want to do first is help you understand just how we measure or determine, and in this case, in the one article they talk about estradiol, so estrogenic activity or hormone activity in the food product, and exactly how we measure that. And we do that using a unit of measure called a nanogram. Who knows what a nanogram is? What is it, Alan?
10 to the 9, negative 9, isn't it?
Yep, 10 to the negative 9, which would be of a gram, which would be what? How many nanograms in a gram? 1 billion. 1 billion. Okay, 1 billion nanograms are in 1 gram. So keep that in mind. So how can we kind of reference 1 billion? Well, this paperclip, just your common paperclip, weighs a gram. So that I can show you what a nanogram is, I'm going to ask Ryan to cut it for me. I've got some scissors, so here you go. Here's a paper clip, some scissors. You can just, I'll give you a plate here so you don't get stuff everywhere, but I'm going to ask you to cut that into 1 billion pieces for me while we're going through this demonstration. Thanks. Okay. So while you're working on that, billion, I need 1 billion. Can you do that?
I don't know.
All right. Don't cut your finger. Okay. So while he's doing that, I'm going to talk about the different types of food products we have up here, and then I'm going to ask another volunteer to try to match up for me the level of, or the nanograms of estrogen in a 3-ounce serving. So I've broken all these food groups down into a 3-ounce serving. Now this is very important because now we're measuring apples to apples, okay? It's different if you do it on a calorie basis or another basis where, don't poke anybody's eye out. All right, you really don't have to do that because you really can't cut it into 1 million pieces. Most of the time when I do that, people just stare at me. So anyway, but you get an A for effort there. Good job. All right. So yeah, to cut a paper clip into 1 billion pieces, they're going to be microscopic. You really can't do it. So a nanogram, for reference, is very microscopic. But what we've got here is 3-ounce servings of some various food products. On the other side, I've got jars of Skittles. Now, we're not going to, I kind of joked earlier that we were going to have a little bit of a party. We're not going to do that, but I did bring some candy for class today. But what those jars of Skittles represents is the amount, the nanograms of estrogen in each one of these food products, okay? So I'm going to step over here real quick. These two full jars represent item number 1. That's together. That's all the estrogen in one of these food products. 2, 3, 4, 5, 6, and 7. There's 7 jars. Can you make sure that there's something in 6 and 7 for me, Jazzy, real quick? I mean, it's not a magic show. I just.
Oh, there is something in there.
What does it look like?
A piece of the Skittle.
Like a little flake maybe of the outer coating, okay? And the 6 is slightly bigger than the 7. So just so you know, I mean, it's hard to see in the back. All right. So what I'm going to ask somebody to do is to come up here and match the amount, whatever they think, based off what you've read and what you might know from public perception or what you've heard, the amount of estrogen using any one of these jars with the product of food. So what I've got, this is a 3-ounce serving of steak. This comes from an animal treated with hormones. Okay, this animal was treated with hormones. This is a 3-ounce slice of a loaf of multi-grain bread. This is 3 ounces of cabbage. This is 3 ounces of beef from organic steer, okay, organically raised. So no hormones used in the process. This is an organically raised steer. We've got some tofu. Now this is a square or bar or whatever of tofu. This is actually 12 ounces. So if you, I didn't want to open it because it's pretty messy. But it basically would be 3 ounces would be a quarter of that little tofu bar. This is hummus. Okay, you guys use hummus with your pita chips and whatnot. And this is actually 8 ounces, so we're looking at just a little less than half of that jar. And then these are veggie burger patties. Each patty is a little less than 3 ounces. Okay? So what I'm going to ask is for somebody to do a matching and put whatever the amount of estrogen they think is in each one of those products and put that jar next to that product. Who wants to give it a go first? I'll tell you what, for the first person that gets it right, I got a $20 gift certificate to Mad Duck. All right, Elle, go ahead. I'll spread these out for you so you can try to match them up.
This is the organic one, right?
That's the organic one. This one's been treated with hormones during the growing phase while they're in the feedlot. You can move the Skittle jars if you want. Okay, so the least amount in cabbage, and then the bread, and then the most in the treated beef. All right, that's pretty standard. That's a pretty typical response or guess, but you're incorrect. You didn't get all of them correct. In fact, let's see, you got one of them correct. Anybody else want to give it a try? Although you aren't far off, but you did only get one of them correct. Nobody else. Nobody's, all right. We'll do one more. If he gets them right, he wins the gift card. If not, then I get to keep it for myself. The organic's on the right. Oh man, hummus. Okay. Still not much in the cabbage or the bread. And still actually, you don't have any correct. A good try, though. Okay, so I'm going to move them around for you real quick, all right? And you guys, anybody else have any guesses? How much do you think that one piece of beef from the treated steer, or the animal treated with hormones during the feedlot process, how much do you think that piece actually has? Do you think L was closer, or L was closer first with the two jars when she had it this way? I'll smooth this here. Let's get that veggie bit up. What do you think? Is that closer? A lot of shaking yes, okay? And that's really is, according to common perception and based off the articles and the information you read, that's what most people come up with, all right? I'm going to move them around real quick for you, and I'll show you the actual level of estrogenic activity in these products. This is the organic one. How many of you guys would have guessed it that way? This table, taken from various different research publications, and I'll show you a couple on the next slide here, represents the food items that are on the table and the estrogenic activity, or the nanograms of estrogen per 3-ounce serving. Okay, tofu being the highest, about 19 million, or over 19 million nanograms. Beef from a treated animal is 1.9. So it'd be 2 pieces of that little paper clip that Ryan cut up there, 2 of those little pieces, which he wasn't able to do, but good try. And the organic beef is a little bit less. But relative to that, is that difference very big? Even relative to cabbage, is that difference pretty big? Not really, okay? That's a small difference, 1.9 to 1.3. Remember, this is a nanogram, 1/1000th of a gram, nanograms of estrogen, in 1.9 in beef from a treated animal, and 1.3 from either organic or natural beef, anyway, beef from an animal not treated with hormones. Tofu on a 3-ounce serving, so 1/4 of that square has 19 million. Any product with soy in it Okay, or that black bean veggie burger, which has some soy in it as well. Okay, any product with soy in it is going to have very high levels of what we call phytoestrogens, or estrogen that are going to stimulate estrogenic activity. All right, so various research has been conducted, and this is all over the world. This data encapsulates information collected in the US, in Canada, Europe. All right, and this is kind of accumulated together, and then I adapted it, or I corrected it for a 3-ounce serving using information like this, USDA, as well as other researchers. Okay, so this is on a 500-gram serving. On the right, 500 grams, which would be a little bit over a pound, 454 grams in a pound, so a little over a pound. You can see how much is in the various products there.
Well, isn't this just one of many hormones? I mean, this isn't even an anabolic steroid, is it?
It is the beta estradiol they give it, yeah, in the
I thought anabolic were all synthetic.
These are synthetic.
Estrogen is synthetic?
Yeah. Well, no. The hormone used for the treatment in the treated animal, in the cow, is synthetic. But that's how much estrogenic activity it creates in the food. But yes, it is, the hormone used in the implant is synthetic. That is correct. All right. This is just measuring the actual estrogenic activity in the food. All right, and so the purpose here is to then display the actual levels of these hormones in food, in various types of food, and to give you a little bit of a perspective on how much estrogenic activity or hormone activity we actually find in beef compared to other foods. Here's how much we produce every day as people, naturally. All right? Pregnant female, approximately 3.5 million nanograms per day, and in some research has shown that number to go all the way up to 19 million. All right, so there's a big variety there, but kind of the lowest number I saw was about 3.5 million. In a prepubertal girl, 54,000 nanograms per day, and a prepubertal boy, 41,500. Me, today, I'm somewhere around 136,000. All right? So this gives you an idea of how much we're producing in our own bodies any given day, naturally. So if I'm producing 136,000 nanograms per day, and I want to eat a steak over 1 pound, which I can't do anyway, that's too much, but for me, but let's say I did, so I was eating 7 grams or 7 nanograms. Is that much compared to the 136,000 I'm naturally producing in a day? Do you think that's going to potentially cause a problem for me? Well, or if I indulge on beef all the time, is it going to take a lot of beef for me to get to any level even relatively close to some of these other foods? It will. Okay? And if I consume that much beef, well, we're going to maybe have some other problems that we're going to talk about in a later discussion. What about lifestyle-induced hormones? Can you guys think of any? Hormones that we might consume for different lifestyle purposes? Okay? So an 8-ounce steak from a non-implanted animal contains 3.5 nanograms, or one from an implanted animal contains 5.1. This is a normal 8-ounce steak. One birth control pill contains 35,000. So again, this just goes to show or puts into perspective the actual amount of estrogenic activity or hormone activity in the food we have in this beef, even beef from an animal treated with hormones compared to various products out there, whether they're food products, lifestyle products, or what we would normally produce in a day. So from a hormone perspective, we're not going to talk about bioavailability. That's a later discussion. We're going to talk about other potential health impacts from foods that we eat from animals. But just from a hormone perspective, is it safe for us? After what you've learned here now, do you feel a little bit better about beef from a treated animal? All right. And I want to see what the FDA has to say, because the FDA, who's the FDA again? You guys know the FDA, right? Food and Drug Administration. So what do they have to say about this product? Because they have to review anything that's going to be used in animals for food production, whether it's something like a synthetic hormone or something like an antibiotic or anything like that. They have to review it. All right, so this article says, since the 1950s, the FDA has approved a number of steroid hormone drugs for use in beef, cattle, and sheep. And these are steroid-based hormones, synthetic. All right, we're going to talk about protein-based hormones in another discussion. That's what we find in milk. But these steroid-based hormones have been approved for beef, cattle, and sheep, including natural estrogen, progesterone, testosterone, and their synthetic versions. All right, they increase growth rate and do a number of other things that lead to greater efficiencies, feed conversion, faster growth, a number of other things. At the end of the day, those things that will benefit the consumer in the long run that's purchasing the meat by reducing the cost of production. The steroid hormone drugs are typically formulated as pellets and placed under the skin on the backside of the animal's ear. Okay, so it's given in the ear. In those articles, it talks about the potential for the estrogen or the hormone to impact, 4,000 cans of baby food? Something like that, okay? You would have to put the implant directly into a muscle, harvest that muscle immediately, and then that one little piece of muscle, because that pellet's very small, grind it up and then distribute it. They're required to be put in the ear. We put them in the back of the ear. Those ears from those treated animals are going to be discarded at slaughter and not used for human food. They've also done so much research that they've figured out that they're all approved, have a 0-day withdrawal period. What does that mean? It means the meat from the animal is safe for humans to eat at any time after the animal's treated. So even if the animal was treated yesterday and we harvested it today, it would still be okay. All right? Because it's still the amount that it's getting. And again, cattle, like people, naturally produce hormones, estrogen, testosterone, daily, just like we do, okay? Similar to the slide we saw earlier. And so this just shows here that through extensive research, efficacy, safety studies that the FDA has conducted, they found no research yet that suggests that there is a concern for human safety, human food safety, from the treatment of animals, or specifically in this case, cattle or sheep, I guess, with hormones. And I spoke a minute ago about now that we know, or we've demonstrated here, that beef, whether it's from a beef from a treated animal or beef from an organic animal, has very low levels of estrogenic activity in the food itself compared to a lot of these other products that are on the table. And I asked you the question, well, does that mean that I can just go out and consume tons and tons of beef all the time? All right. Well, the answer is what? No, because there's other issues, right? Other potential health issues. surrounding beef. And that's what we're going to talk about in the next discussion. We're also going to talk about beef versus some of these other food types in terms of bioavailability of key nutrients, essential nutrients. All right, we're going to talk about things like beef versus certain vegetables like broccoli, which both have relatively high protein levels, and why those proteins from beef, or not all, I should say not all proteins are created equal, and proteins from meat, not just beef, but all meat or products that come from animals are actually better used and are more bioavailable to our bodies. And that'll be the next discussion we have.